Let's see. So how was the first program? Did you guys have any trouble with it? Having to remember how to do some of that? Not too bad. I mean, they looked good on my end. I didn't know how much you struggled getting there. So good, good, good. All right. Well, let's pull up our curriculum today and see what we're looking at. We do not have a program this week. We'll have one next week. They generally don't do a whole lot of back to back. We will have some, I'm sure, but not this week. So let's see. Going to our grade screen. We're on 1.03 data structures this week, and there is a documenting and debugging program. I've looked ahead. I've got the template set up as a Google Doc since that isn't working right if it's not a Google Doc. So it'll copy it for you and let you type. But we'll look at 1.03 this week, see what kind of fun stuff it's got for us. Data structures. The data is impressive. With 2.5 quintillion bytes of data generated each day, you could say the world runs on data. Now, I wonder if they're just guessing this or how do they get that number? But I'm sure there's lots of data generated. How much data is that exactly? To get a better understanding of the sheer amount of data that's generated, let's break it down to a minute instead of a day. So let's see. Every 60 seconds, Amazon makes more than $250,000 in sales. $250,000 in sales every minute. Google processes more than 3.5 million searches every 60 seconds. And that may be consistent around the clock since Google's used worldwide. I mean, there's billions of users. Instagram, more than 45,000 photos are posted to Instagram every 60 seconds. There's more than 15 million text messages sent every 60 seconds. 4 million videos played on YouTube. Good gracious. And more than 500,000 snaps are shared on Snapchat. So, yeah, there's a lot going on in the digital world in just 60 seconds, in just 1 minute. So, data structures to the rescue. So, thankfully, programming can help manage all this data. Well, programming has to manage all that data. It's the only reason any of it works. Python has a number of built-in data structures that allow you to store, retrieve, and manipulate data. These structures can be assigned to variables. Of course, if you need a review of variables, see the reference section. We have our reference right up there. Data structures such as strings, lists, and dictionaries. So we're going to add dictionaries. We used lists some last year. We did not get into dictionaries. These help programmers organize data in an efficient way. So a string, we know, is just a sequence of letters, numbers, and symbols. A word is a string, or it could have numbers or whatever. Python strings are immutable. Let's see what immutable is defined as. Unable to be changed or altered. A string is a string is a string, right? Meaning they cannot be changed. Because of this, strings can be used as dictionary keys. So a dictionary has keys. So let's see. Let's go to list next. A list is a container that holds items in a given sequence. Yeah, we created some lists last year using those square brackets where we made lists of different words, and we could reference the 0 indexed list item or the first or the second or the third. So a list is a container that holds items in a given sequence. So lists can contain anything. Like you could put other lists in a list, and you could easily change lists. Remember we had that where we could append and add something to a list, or we could delete like the second entry in the list. We could replace it with a different entry. So we can change lists. So if you want to have a record of students that volunteered for the beach cleanup each week, you might use a list, because next week you may have to take away a couple students that are not going to come and add some new students that are going to come. And since lists are mutable, which means they are able to be changed or altered, you will easily be able to remove students that didn't show up and add new students when they do. For that person who didn't sign up but had to come with their best friend, so you got to add them to the list that they were there. So that's a list. Now let's compare a list to a dictionary. A dictionary is an unordered set of items, and like lists, they are mutable. I mean, they can have their state changed, so you can change the dictionary. Lists access data according to the position, right? The 0 item, the first item, the second item. But to access values of items in a dictionary, you must use a key. All right. For example, if you were keeping track of places you would like to volunteer around the world, you might create a dictionary that pairs a country with a city that you identify. So when you search for a country, you would immediately find the corresponding city. All right. So it sounds like if we were doing like capitals or something, you would have the key of like the United States, and then next to the key would have Washington, D.C. So it would have the country. So that, but you have to have a key. It's not like the first item, second item, third item. There's not in any order like that. It's like each of them have a little tag, which I guess the key could be numbers. This is the first item, second item, third item. But if you did that, you might as well just use a list. Forget the numbers. So let's see. All right. Data science and Python, an ideal match. Nowadays, more and more companies are collecting and analyzing large amounts of data to keep their businesses on a cutting edge. It's called data science. The deep understanding and application of statistics, algorithms, programming, and communication skills. Python is popular as a programming language among data scientists, not only because of its wide set of data processing libraries, but also because it's easy to learn and use. Okay. Yeah, data science, if you can get into numbers of stuff, it's very, very interesting. Strings. Now, we definitely know what strings are. We've heard of those. Strings are one of the most important building blocks of programming. A string is a sequence of characters, letters, numbers, symbols that are either a constant or they could be a variable. Remember, Python strings are immutable, which means they can't be changed once they're created. String example, define main. Print, let's print out this string. And there's no way to go in and take the word print out and add something else. You just have to delete the string and type a new string without the word print or something, right? So it's immutable. We can't play with that. So Python allows you to interact with strings in lots of different ways. So let's review. We can concatenate. Strings can be grouped together. If we put that little plus in between there, we could put programming is fun. So taking 3 strings and print them together as one string. So we can concatenate strings. So that's something we could do, because we did do concatenation last year. Usually we put a variable in the middle because that may change, but the strings themselves don't change. Repetition. Strings can be repeated or repeatedly concatenated. My string equals programming is fun. So we could print my string, which was the variable, times 3. And remember, if we're doing multiplication with the string, it'll just repeat the string. Programming is fun, programming is fun, programming is fun. If my string was an integer, then it would do the math 3 times whatever that integer was or whatever. But yeah, because we learned about multiply. When we learned about multiplying, the first thing we did was a mistake that it did this, and we had to figure out, oh, wait a minute, if you don't yet make sure it's an integer, you won't get what you want. We can index. So indexing calls for the specific position of a character. And remember, Python starts counting at 0. So we could say print Python and index just the 0 character, which is the first character in our mind. So it would just print the P. We didn't change the string. We just indexed it and say only print the 0 character, whatever the first one is, the P. We could slice. Remember, we did do some slicing where we say just print the 2nd through 4th. So it would skip the 0, it would skip the 1st, and it would just do the 2nd, 3rd, and then it would stop when it got to 4. Remember indexing, 4 tells it, hey, don't print number 4. That's where you stop. So it just prints the 2nd and 3rd character in the index. But yeah, I've got to remember it does not include that. And we can actually check the size using the length command, len. Print the length of this string right here, which of course is 6 characters. Just calculate it. So we can do a lot with a string without technically changing the string, just using pieces of it, adding it together, putting things together, seeing how big it is. We have a lot of stuff we can do. So that's a good little reference for us on page 2. So good. I'm going to pull up something else I want to talk about then, because this I found really cool. And since it talked about data and how you analyze data, I thought this would be a little fun math aside anyway. So I'm going to give you guys a little math lesson in the middle of our computer lesson, just because I know you like cool math stuff. And this is a really cool math thing. I had not heard of this till last week. I learned of something called Simpson's paradox last week. And that's where you can take some data, and politicians are great at this. Hey, look at this data right here. This means that we need to do this, right? And the data can totally be used to lie. So let's say you've got this person that you love in your family that's really sick, and you need to rush them to the hospital. And you've got all this data at the hospitals. Do I need to take them to hospital A or hospital B? Well, let's compare hospital A and hospital B. So some people show up in poor health at the hospital, right? They got to go to the hospital because they're really sick. Some people need to go to the hospital, but and generally they're in good health. But broken leg, I mean, something happened, they go to the hospital. So let's look at two hospitals and compare the survival rates of people that show up at these two hospitals. Cool thing. All right, so hospital A, here's the survival rates. They had, let's look at their last 1,000 patients. Their last 1,000 patients. 100 people showed up at hospital A that was in poor health when they came in. They were in critical condition, and only 30 of them survived. 70 out of the 100 died. So they didn't have a very good survival rate for people in poor health. And that's not necessarily the hospital's fault. When people show up in really poor health, they may not be able to save them. Hospital B had a lot more people show up, 400 people in bad health, but they were able to save 210 of them. All right, so it's like, okay, well, looks like Hospital B is a lot better choice. And then breaking that out, of the last 1,000, if 100 of them were in poor health, there was 900 that was in pretty good health. And 870, 30 of them died, unfortunately, for whatever complications, infections set in, who knows. But they were able to save 97% of the people in good health. Hospital B only had 600 because most of theirs were in very bad shape. So out of their 1,600 and 590 survived. 10 of them developed. So both of these we look and say, well, Hospital B is where we need to take our patient. But let's add these numbers together to look at the top 1,000. If you just looked at the last 1,000 patients, did not break it down, and add these numbers together, what does the numbers look like? 900 out of 1,000 survived at Hospital A. So you're saying, well, 90% of their patients lived. Only 800 out of 1,000 lived 80% for Hospital B. So if you just look at the total 1,000 patients, hey, Hospital A is a lot better hospital. That's where I need to go. But if you broke that down, in both cases, Hospital B outperforms Hospital A. Statistics can lie, because this you have to break down to the subcategories. If you break it down to subcategories, it tells an entirely different picture. And there's real life other examples you can find that do the exact same thing. The aggregate, the total, gives you an entirely different picture than if you broke it down into some subcategories. I just thought that was fascinating. And politicians know this well. And one politician is going to be arguing Hospital A is where all of our money needs to go. And the other politician is going to be saying, no, Hospital B is where all our money needs to go. And they're both going to show you facts that support their arguments. Fascinating. Math can be so cool. My wife said, that's just one of those cool math things that mathematicians get excited about, isn't it? Because I told her about it and she wasn't nearly as excited. I'm like, this is a cool thing if you're a math person to understand that you can totally change the whole picture just on how you present the data. Statistics are cool. I just have to say that. All right, let's get back to our lesson. But since it's talking about data, I just wanted to throw that interesting data fact that I ran into last week. So, all right, page 3. We talked about strings. Lists. Now, strings can print basic information, but they can only get you so far. So if you want to update or change that information without creating a new string after string after string, then a list is a better choice. Lists are similar to strings in a few ways. Like a string is an ordered set of characters, which often make a word, while a list is an ordered set of values of any type. Our list could be all numbers. Our list could be all strings. It could be a mixture. Many of the actions you can use with strings can also be used with lists, like indexing or slicing. Elements are the values that make up a list, and each value is indexed, identified by an index. Choose lists when you're working with similar data types. This allows you to streamline your code and perform operations on multiple values at once. So yeah, if you just got a bunch of different strings that you're needing to organize, a list may be a great way to do that. Like if you want to track and compare a dog's weight during its stay at a shelter, maybe you use a list. You have the dog ID number, his weight on week 1, his weight on week 2, his weight on week 3. So we can, if you need help with list syntax and how to do that, refer to the reference because it doesn't go into a whole lot of details because we learned lists back in programming 1. But if you need refreshers on that, let's look at this example and their Python guided activity. So basic lists in Python. So this program has a list of animals currently living in a wildlife, what goes a long ways down here, in a wildlife and pet rescue center. All right, so they created their main function with 2 lists. First is a bird list and a dog list. So we've got a parrot, a finch, a cardinal, a macaw, and a cockatiel. And we have a dog list as a chow, a boxer, a beagle, a bulldog, and a poodle. Add birds and dogs. So if you want to know the total number of animals and birds you're responsible for at this shelter currently, length equal the len is the length command. And let's add these 2 lists together. Add the bird list and the dog list. Print there are, and so we save that as the length. So we're going to print that. And remember, we're going to use str when we print numbers and strings together. There are blank animals currently housed at the Wildlife and Pet Rescue Center. All right, then remember we can index and say, what's the dog in index position number 3? List that dog that was rescued. Print the blank dog was rescued this week, Maine. So list 3, we would expect it to print, this is 0, this is 1, this is 2. It should print the bulldog, right? Because that is the index number 3 position. So if we run it, there are 10 animals currently housed at the Wildlife and Pet Rescue Center. The bulldog was rescued this week. Okay, and that would be right because we see 5 birds, 5 dogs. So that's a good example for us to go back and refer to. I don't remember what next week's program is going to be, but I'm kind of betting there's probably some links, maybe lists or dictionaries, just because that's what we're learning this week. But the length command right there. So lists allow many values to be stored together. The length function tells us how many are in the list. The print function displays the bulldog when we reference it as the 3rd index. And if you guessed beagle, yeah, not 1, 2, 3. Remember, Python starts with 0. That's the big thing to remember. Is that got to remember Python does not start counting with 1. It counts 0, 1, 2, 3. So, all right, let's look at the next slide. Define main. Read the code, predict the output, review the output. Oh, we then we're supposed to change the list by replacing, appending, and deleting values. So, chow, boxer, beagle, bulldog, poodle. Same list. Give us the length of those 5 names of dogs. Print the original list. So it'll print the list. And then print just a blank line. So we want to give some space. Replace a value in the list. Names 1, Bichon. So we want to replace boxer with this one. And it names 1. So let's see what the print names print. Let's run the program. The original list, chow, boxer, beagle, bulldog, poodle. Bichon replaces boxer. That's what we printed right there. And then when we print it again, all we did is said, hey, take whatever's in the number 1 position and change it to this. Well, that was real easy to do. It just replaced boxer with Bichon. We didn't have, we could have done it by deleting the first one, appending, adding a new one, and then printing it that way. And it would have just added it to the end. If we use the append thing, append list with a name. So let's see there. How did that work? Was it just append? I better look that up. Let me go to the reference because might need a refresher on append, and I haven't used it since last year either. Lists. So there's the list. Append. Oh, you got to tell it the name of the list dot append. So if we go back here, right there. So on the list of names dot append, if we just put Bishan with the append, and let's make this a comment just so instead of using that command, we use this one, names append Bishan. Oh, it has an error. What did I do different than the reference said? Oh, parentheses, not the block. There we go. Append with the parentheses. See, this just added it on at the end. And we still have Boxer because I didn't do the delete command. If we did the delete command, remove, there it is, delete test grades 2. So if we said delete names, this one I would use the index, wouldn't it? So if I said delete names 1 and add Bishan, see, I got rid of the Boxer and replaced it with Bishan, but now it's in a different order. So that's the difference between deleting and adding something to your list as opposed to putting it exactly where you want it to be. Does that make sense? Kind of understand how that works? This command just replaces the number 1 indexed name with the new name, where this uses 2 commands. I deleted Boxer because the Boxer, somebody come got the Boxer. I deleted that and then I added the Bishan, but it adds it on to the end. So if these were in specific cages, like the Chow is in the first cage, the Boxer's in the second cage, and I'm going to keep track of them in order of the cage so I know which cage to open. You know, I would want to replace Boxer with Bishan because the Bishan got put in the cage the Boxer came out of. I should use this command to put that exactly in cage 1. If I'm just keeping a list, I can delete it and then add this, but it rearranges my order. And it's 2 commands. If I can do it in 1 command, that's even better. If I know I'm deleting something and adding something else, I can do it in 1 line. All right, let's look at slide 3. Read the code, predict that, review the output, try changing the list by replacing pin deleting values, run program. Okay. Names, Chow, Boxer, Beagle, Bulldog, Poodle. Back to our original list. What's the length of that? Print the list. Okay. And nowhere did we use the length. We don't print the length, but we calculate it. Replace a value. Replacing the index 1 with Bishan. That's what we just did. Now it says append a value to the end of the list. Now we got a 6th dog, apparently, right? Append Boston Terrier. So we're adding Boston Terrier. This is added to the list. And then we're deleting something. Now we're deleting whatever the number 4, the Poodle. Poodle got deleted. And then it says insert a value to a specific position, names.insert for German Shepherd. So let's compare and see how this works. If we run this, there's our original list. All right. Chow, Boxer, Beagle, Bulldog, Poodle. Then we did that command to replace the index 1 item. So Boxer got replaced with Bishan. Then we added Boston Terrier with the append. Where was that? Right there. The append command. So it just adds it on to the end of the list. Then we delete names 4. So Poodle is now gone. 0, 1, 2, 3, 4. That's the 4th item. And it's gone now. It goes straight from Bulldog to Boston Terrier. And then we had it names.insert 4, German Shepherd. But we didn't print it again. Let's print it to see what it looks like now that we've used that command. So we can see exactly what did the insert do. Okay, run program. There it is. It added it, but it didn't add it to the end because we told it put it in position 4. So we've learned a new command here. Several changes occur. The value in index 1 is assigned a new value. The boxer was adopted and replaced with the Bichon. Then the append function was used. Then the insert function. And then printing each list let us see that. So multiple ways to play with our list and change things. We can just print the original list. We can replace something in the list with a new value. If we know exactly the index position, hey, take that item, number one item, and let's replace it. Or we just want to add something to the list. So there's our command. Just add another thing to our list. So now I've got 6 things from the list. Or I want to delete one of them, and I specifically want to delete the item 4. So 0, 1, 2, 3, 4. I want to delete number 4 items. I can just use the delete out of the list. And if I want to insert something, but I don't want to put it at the end because it added Boston Terrier to the end with the append, we can use insert instead of append and tell it exactly what position to go in and what do we want to insert. We want to insert German Shepherd, but we don't put it at the end. We want to put it in the number 4 position. So it added it there instead of adding it after Boston Terrier. All right, a lot of cool stuff we can do with lists there. So remember, this is on page 3. If you need to review this, we've got another slide. We're going to do something else. Read the code, predict the output. Using the comment on line 9, fill in the missing statement to remove the cockatiel. Okay, so we have our comparing 2 different lists. Parrot, parakeet, cardinal, macaw, cockatiel, parrot, finch, cardinal, macaw, cockatiel. Delete a value from the list on line 10. Okay, we didn't print either one of these lists up here, but we want to delete it and then print list 1. And then say, do they equal each other? Print. Does bird list 1 equal bird list 2? And then compare 2 identical lists, chow, boxer, beagle, bulldog, with the same command. Compare list 1 to list 2. All right, so the first thing it wants us to do is delete value from the list. Delete a value. It doesn't tell us, oh, this over here tells us to remove cockatiel. So we want to delete the cockatiel. So delete bird. It didn't tell us which list to delete. Oh, from bird list 1. It tells us over here, bird list 1. Okay. Bird list 1. Let's see. We just do index 0, 1, 2, 3, 4. Delete item number 4. All right. Let's see if we have any errors with that. I believe that's how the delete worked. Nope, that's not how it worked. All right. Let's go back and look at the delete test grades 2. Did I mistype bird list? Oh, I did not capitalize the L. That's where my error is. I didn't use the right variable name. Oh yeah, it told me bird list 1's not defined. See, I didn't type the right name. All right, let's try it again. Cockatiel's deleted from the list, so it's only parrot, parakeet, cardinal, macaw. And so the first time it prints false when we say print bird list 1 equals bird list 2. The second time it prints true because it compared the 2 lists of dogs and they're identical. So that's true. All right, that's interesting. Instead of having to use an if statement, if compare these, are they the same, print true. If they're not, print false. We can just say print this equals that, and it'll either decide it's true or not and print that for us. So there you go. These are some great examples teaching us how to use all these lists. All right, let's look at our last page, page 4. Dictionaries. We need to compare here, see how dictionaries work. Just like a traditional Webster's dictionary, dictionaries in Python have an index of words, keys, and definitions, values for each. It's similar to a lock and a key. Locks are fitted to individual keys that never change. The important thing to remember about dictionaries is that values can change, so they can be of any type. But the keys cannot change, and they must be immutable. The key is always the key. It's like we talked about capitals earlier. We could move the capital from Washington, D.C. somewhere else. So it'd still be United States would be the key, The capital could change, which it did in our history. Washington, D.C. was not always the capital of our country. So think of a phone number. The key is the person's name. That's a good example. That doesn't change, but the value in the dictionary is the phone number, which can change. So let's see. If we're going to create a dictionary of dogs and their current names, you could use the following. The dog ID number, because when the dog comes in, we assign it an ID. And what is the dog? So in this case, I guess the key goes second in a dictionary. Here's a dictionary example. Dogs, Chuck, 956, Spot, 857, and Sunny, 140. Print, Chuck is ready for adoption. And then print dogs, Chuck. Oh no, that is the key, I guess. Let's see. What is the output? Chuck's ready for 956. So the key was Chuck, I guess, and it printed out. Hey, go get dog 956. Because when we printed, we used the key Chuck, and it looked up to see what Chuck was. He was number 9. And notice there's a colon after that. All right, let's play with this here. Let's practice using dictionaries. Dictionary example. John, 96, Carl, 87, Julia, 100. Julia raised the most money. Print, student, Julia. Public functions loaded. Okay, let's run this. Julia raised the most money, 100. So we create a new dictionary called student, which has 3 initial key value pairs. The student name is the key. So what's before the colon is the key. That's what you can search using. That's the key. And the student grade, it's not the grade. It's the amount of money they raised. This could be grades. This could be test grades. But then we print the value 100 using the key Julia. Because it says she raised money. It was not the grade. So they got to confuse themselves there. So yeah, the key goes before the colon. All right, let's see. Read that, but predict that. Explore by changing and adding another key and its value to the dictionary. So dictionary example. John 96, Carl 87, Julie 100. Print current dictionary. You print it. Add a new student record so we can update. So update is used. So our reference, go back up there. Dictionaries, right there. So with dictionaries, we can use length, LEN, printing a key's value, just print like Jan, and it'll look up and say Jan's 435. Traverse in a dictionary to access the key and corresponding value. A loop makes this process easy. So if we did 4K, V, the key and the value in student.items, it would go through and print each one. Dan 327, Jan 435, Steph 980. Append is update. We use append with lists. We use update with dictionaries. And look, we have to put it in parentheses, and then we have to put that in squiggly brackets because dictionaries use squiggly brackets, lists use square brackets. And remove is the same, delete. But instead of telling an index number, you index this index key. You don't say 0, 1, 2, 3, 4. You use the key to delete that student. So, all right. So student update Carson. Let's run this. See what this does. John, Carl, Julia, and there's their scores or whatever. And then they added, updated Carson. So let's see if we can use that delete. Delete Carl. Let's do that. And let's try DL. It was called student, right? That's the name of our dictionary. Yep. Student, parentheses, squiggly bracket, Carl. Oops, make sure I do that right. Quote, squiggly bracket, parentheses. I think that's right. Nope, can't delete function cell. What did I do different? Oh, square bracket. Okay. Don't need either one of those, just a square bracket. Delete Carl. So this works just like a list. Put the name of the list and put it in brackets, whatever the index number is. There, we deleted Carl. We added Carson, Lee, and Carl. All right, we've got a minute to 200, just finishing up here. Let's look at the next slides. Working with dictionaries. Got John, Carl, Julia, printing that. Oh, deleting Carl. Hey, we were ahead of the game. We just deleted Carl on the last one and print. So there's how we delete a student. That one's pretty simple. And using comments, fill in the missing code. Add the missing student. So we're going to add a new student. There's the original list. And we've got to, let's see. Instead of append, it was update, right? So we got to do student.update. Now see, do we use squigglies? Parentheses and squigglies. Parentheses and squiggly brackets. And we're adding Jackson, comma, right? Is it comma? No, the whole, just right, colon. And he is a 45, squiggly brackets, parentheses. The original list, John, Carl, Julia with their grades. Jackson's added to the list. There it is. That's the one we did. And then they deleted Carl because he moved and transferred away. He's no longer in the class. Okay, so these are good examples. If we're doing this next week with a dictionary, which I'm betting we're doing something like that, that gives you good examples for that. Let's look at the assignment real quick. Since programming's coming into the room, it says, read this lesson. Let's do the quiz. Which the following best describes a list? What's the difference between list and a dictionary? When programming dictionaries in Python, which of the following is true? Okay. Which of the following Python functions is used to return the number of characters? If we want to know how many characters in a string, which of those? And which of the following best describes mutable? Remember, mutable can be changed, immutable can't be changed. So, all right, fellas. I'm learning a lot of cool new stuff with dictionaries and all the things and play with those. So you guys have a great week. We'll see you. This is a B-Day Friday, by the way, for all your classes. So if you need any help, Friday's a B-Day. See ya.